A warm welcome to the third film in our Building Bases series. In it, we take a look at the design principles that apply to the construction of the base for a building with double-skin masonry walls. Let us go back to the visual effect created by the design of the building base. The way the aluminium panels on the right here appear to float above the ground matches the material used. It almost looks as though the thin sheet metal has been bent by the pressure of the ground. A brickwork facade, on the other hand, with its associations of a great weight bearing down on the ground, would never be designed with this floating feel. You already know that the structure of a wall changes at the point where it comes out of the ground. There would be no point in continuing an attractive and costly facing skin underground where it's invisible. As a result, the portion of wall below ground is of a simpler construction than the double-skin masonry wall above it. Construction at the base of a building starts with the load-bearing structure. The reinforced concrete foundations, the reinforced concrete slab and the masonry walls are built to completion. The foundations are wide enough to serve as a base for the facing skin, as well as the load-bearing superstructure. As you can see from the lines on this drawing, the final ground level and interior floor levels are the same. The first step is to apply the vertical damp-proofing course underground. If there is a danger of vadose or groundwater, the floor slab must also be damp-proofed. Damp-proofing to combat soil moisture generally takes the form of a thick, bituminous coating. The exterior wall must also be damp-proofed up to a height of 30 centimeters above the final ground level in order to protect it against spray. The damp-proof course is followed by insulation, with a water-repellent insulating material being used up to the top of the damp-proof course. The area that will support the facing skin must also be insulated to prevent the formation of a thermal bridge. This is done using either pressure-resistant water-repellent insulation or insulating blocks made of foam glass. The outermost layer or facing skin is then laid with a finger gap or rear ventilation cavity to provide thermal insulation. The facing skin is tied into the load-bearing brick wall above the height of the damp-proof course. Interior fit-out work can be carried on at the same time as the laying of the facing brick skin. The foundation pit is backfilled and protective matting is laid on the ground at the junction with the facing skin. Unjointed butt joints in the brickwork of the facing skin both allow any water that penetrates behind it to run out and provide ventilation if the gap between the two skins is 4 centimeters or more wide and designed for rear ventilation. Here you can see an actual example showing the base of our Mitte Primary School in Leipzig. Let us run through the various construction layers again, one by one. Reinforced concrete load-bearing structure, damp-proof course up to 30 centimeters above ground level, uninterrupted insulation layer including insulating blocks and brickwork facing skin. The differences are the 5.5 centimeter wide rear ventilation gap and the position of the drainage opening in the facing skin, which is combined with the air vent and drains out onto the paved area. Now let us look at how facing skins are set into the ground in terms of the materials used, here in the case of man-made bricks. For our School of Hotel Management in Berlin, we ran the bricks right down into the ground with no transition because they were able to take the humidity load. At our Weiler Conference Center, we laid precast concrete elements at the base of the building to prevent the white sand-lime bricks from being stained by water spray. With natural stone-facing skins, a weather-resistant stone should be chosen for the base if the facade stone is unable to withstand the humidity load, as in our Provost Church in Leipzig. Impervious natural stone can also be used below ground level. This is the approach we took with the house pictured on the right here. So, as you can see, the design of the base of a building depends on the characteristics of the facing skin material, whether it is natural stone or a man-made masonry product. Summary. The visual aspect of the base of a building should be designed in accordance with the materials used. The structure of a wall changes at the transition from below to above ground because the design of the invisible part of the building shell below ground is simpler than that of the double-skin masonry wall above it. The standard structure for the base is as follows: reinforced concrete load-bearing structure, damp-proof course up to 30 centimeters above ground level, uninterrupted insulation layer including insulating blocks, and brickwork facing skin. Please don't miss the fourth film in our Building Bases series, in which we discuss how the construction of a basement or cellar affects the way in which the base of a building is designed.